So two more important key characteristics of graphs are the domain and range, and this should be mostly review, but remember the domain is all the x values of a function, and the range is all the y values. So domain is like all the x's, range is all the y's. Basically from like the lowest to highest point. Where do you go? Sometimes these can be discrete or like individual values. Like on this one, the domain is just -3 because it hits at -3, and -1 because it hits at -1, and 0, and 1, and 2, and 2.5. And the range would be all the y values. So it hits at -2, and -1, and about 0.5. And I have two different ones at 3, but I'll just list that once. I hit at 3, and it hits at 5. But typically what you're gonna see are not just discrete values, but actually continuous functions, a collection of points like this. This is a collection of just a bunch of points that are all so close together you can't even see them. So in this case, instead of trying to list out all those bajillion numbers, I'm just gonna be like, hey, so the domain is just everything from here to here, because we're lazy. And the range is everything from here to here, and that's it. So, for example, the domain of this one is all the x values. So it's 0.5, and it's 1, and it's 1.5, and it's 2.7, and this arrow means it's gonna continue forever. And so I know like it might look like it's gonna get really steep, but it's still gonna keep going to the right. There's nothing stopping it from going that way. So the domain goes all the way to infinity. Also on this side, it also continues forever in that direction. So the domain is from -infinity to infinity. Another way of saying this is just all of the numbers. All the real numbers are in the domain. This little symbol represents all real numbers. You can write it out in words if you want. Basically, everything that's not a complex number is in the domain. So use this symbol or just write out all real numbers or write -infinity to infinity. Any of those are fine. The range on this one's going to be the same because as we look at the y values, it goes to -1 and -2 and -3 and so on forever. Same thing going up, it goes forever. It hits everything from -infinity to infinity, also known as all real numbers. That's just an R with a line drawn through it. Let's try another one. So for the domain, as I'm looking at the x values or from left to right, the graph again doesn't stop. It goes forever to the right and forever to the left. So the domain is once again all real numbers from -infinity to infinity. But the range is not. As I go up and down, I see that I can hit at 0 and 1 and 2 and 3 and go up forever, but the graph does not go down forever. It doesn't hit anything below 0. So for my range, there's a couple ways you can write this. As an interval, I would say it goes from 0 up to infinity, because it literally goes from 0 and up. It includes the 0, and so rather than a parenthesis, I'm going to use a bracket, which means the 0 is included. We always use parentheses around infinity just because they never end, but if you ever want to not include it, you do a parenthesis. If you do want to include the endpoint, you do a bracket. Another way of writing this is you could say the y values just have to be greater than or equal to 0. These mean the same thing. This is just an interval notation. That's in set notation. All right, and the last little characteristic I want to talk about is very straightforward. But when you look at a graph, there are little like hills and there's little valleys. And each little hill is called a maximum point, and each little valley, like the bottom of a bowl, is called a minimum point. Obviously, this is not the overall maximum, because that's the biggest maximum, but it's the maximum of like this general area. And so we call that a local maximum or a relative maximum, because like relative to everything around it, it's a maximum point. Or like here, based on this little local area, that's a minimum point. Just by the way, minimum plural is minima and maximum plural is maxima. So each like top of the hill we call local or relative max. Each bottom of the bowl here we call a local minimum. Obviously this goes down to negative infinity, so that would be the total minimum. But for example, if I wanted to identify the relative maxima and minima here, there's not really any maximum points. I mean, it goes to infinity, so you could say infinity if you really wanted to. But there is a point right here that is a minimum point, and that's the point 0, 0. That's it. Or like something more complicated like this. Each top of the hill here, this would be a max at -5, -1. This, or I should say local. Local or relative. This is a local max right here at 1, 5. This is a local max here at 5, 2. Just each of those height, like the tip of the mountain here. And each low point is a minimum. So like 0, -4 would be a local minimum. Same with 3, -3. And that's pretty much it, because it just keeps going.